you're probably getting tired of seeing the same basic graph over and over and over again. So sine, remember we start on the midline, divided it into quarters here. Cosine started on the top, divided it into quarters as well. So there's the points. So realize right in the middle is the midline. Those are the maximum, minimum, max, minimum, max, midline in the middle. So looking at this, we're going to try to create 2 points and then model our equation from that. So the distance dt between the bob of the pendulum. So there's a pendulum swinging next to a wall. So you can picture here's a wall, and then we have like a pendulum, that's one of those things, and it's swinging back and forth. So the distance between the bob of the pendulum and the wall as a function of time can be modeled in this form. We could use cosine, depending upon what they give us here. So at time t equals 0, when the pendulum is exactly in the middle of its swing, the bob is 5 centimeters away from the wall. So that's basically, by telling us that it's in the middle, is telling us that that is the midline point. So we're given a midline point that when time is 0, its distance is 5. All right. Then the bob reaches the closest point to the wall. So closest point to the wall, the minimum distance. That's going to be, because remember, we're modeling distance. So the minimum distance, basically. So that's giving us a minimum. And that point is 3 centimeters from the wall, and that's 1 second later. So after 1 second, we're 3 centimeters from the wall. So do you guys see how I came up with that point? That is very important. So let's look at the graph up here. What do we have? We're starting on the midline, so we know it's sine. Then we go to our minimum, so it's actually going to be negative because we're going down to our minimum next. So we're going to have negative sine. Let's figure this out, though. So we have 0, 5. If we were to plot the points, it would be 0, 5. Then a quarter of the way would be down here at 1, 3. Just going to plot that same thing, right? So let's figure out our amplitude. 5 minus 3 is 2. So our amplitude is 2. So far we have negative 2 sine. It's negative, remember, because the way it's flipped. And then our midline is 5, right? They gave us the midline y value. It's 5. I don't even have to put the y-axis here. So 5 is the midline. So we're off to a great start here. So we need to know our period. Well, we know a quarter of the distance. Quarter of the distance is going to be the difference in the x values, which is 1. So the whole distance is going to be 4. So remember, our period equals 4. So in other words, 2 pi over b equals 4. So 4b equals 2 pi. So b equals pi over 2. So that's what's going to go in front right here. And then looking at this, we're starting right on the y-axis because x equals 0. So it's right on the y-axis that we're starting. So depending upon that value there, so actually it's just going to be x. I don't even have to worry about a shift left or right. And if it helps, draw a coordinate plane. Draw the grid if that would help. That probably would have been more beneficial if I had done that. So you could see where those points are at, right? So that way you could see, hey, 0, 5 are right on here. And then 1, 3 would be like right here. So that way you can visualize where you're at. That might help quite a bit. I'll probably do that in the next problem. So let me see. I'll go ahead and go through one more. So Rania is riding a Ferris wheel. Her vertical height off the ground is the function times given by, and this time they're telling us let's do cosine. So that's kind of nice. When she starts moving, she is at a height of 10 meters off the ground, which is as low as she can go. So they're giving us the minimum. That's nice. So that's at t equals 0. She's 10 meters off the ground. And then after 20 pi seconds, she reaches her maximum. So then we're at a max. At 20 pi seconds, a maximum of 30. So drawing a coordinate plane. So this is cosine. We're starting on our minimum, though, at 0, 10. And then after a while, we'll reach our maximum here. Which is at 20 pi. So just kind of picturing it, going through it. Remember, we're drawing these, there's the quarter, that's a halfway. So just real quick, so it's negative because we're starting on the minimum, so it's going to be negative. And then the distance from 10 to 30, that total distance is 20, right? That's the total distance is 20. So we want half of that for our amplitude. Then what is our midline? Our midline is going to be the 10 away from that. Once you have that, once you have the amplitude at 10, we know we could just add 10 to get up to the midline. So if we're currently at a height of 10, we add 10, we get up to 20. So our midline is 20. Which makes sense. It'd be right in the middle. And then our period, well, halfway is 20 pi, so the full period is 40 pi. So 2 pi over b equals 40 pi. That's over 1. So cross multiply 40 pi b equals 2 pi. Divide to get 1 over 20 for b. Oh, and it's actually supposed to be t now that I'm looking at this. Technically, because it's h of t, right? Same thing with this is d of t. So I should be putting t. I've gotten things like that wrong in the past for that. That's the main idea. So just picture those 2 points and how they go with the graphs and what you know, and measure it all and basically substitute it in, and that's it.